Hi guys, welcome back to your math lesson out of the packet again today. Today is going to be Tuesday, March 31st, so I'd like to wish a happy belated birthday to Ava, whose birthday was the 27th, Gavin, whose birthday was the 27th, Aiden, whose birthday was the 28th, and then Savannah, whose birthday is today. Happy birthday to all you guys. I wish we could have celebrated together, but we're staying safe at home, and that's what's important. Okay, so today in your multiple choice packet, guys, I want you to do questions 19 through 26. That should be where we all left off, 19 through 26. You can cross out 23 and 25, those are repeats. So we don't need to do those. And then in your short answer, we will do questions, we'll probably get to questions 9 and 10. Hopefully we can get to 10. I think we gotta, yeah. We'll have time to get 9 and 10. All right, so question 19. Let's start there. So it says, which ordered pair would not be a solution? So circle that word not. Anytime they give you something like that, you wanna make sure that you're looking for what's not the solution. And I'm just gonna show you guys the strategy. We're gonna go into our y equals, plug this into our y equals, and check the table for the points. Okay? Or you could plug each one of these points in for x and y and see which one doesn't work, but that's kind of time consuming, so let's do it the shorthand way. So you go x to the third minus x, go into that table, and let's slowly but surely check off each point. So negative 460, is that in there? Yes, it is, so that is a point. We're looking for which one's not a point. Negative 3, negative 24 is in there, so that can go. Negative 2, negative 6 is in there, and negative 1, 0 is the point, not negative 1, negative 2. So D is your answer there, okay? All right, question 20 says, what are the zeros of the function? So in this case, you can do this a couple different ways. We have you guys factoring this, so let's do the factored way, and then we'll check it using our strategy. So this is a trinomial. Remember, when you factor, you can either do GCF, dots, or trinomial. This does not have anything in common, so it's not going to be your GCF. This is not a binomial, so it's not going to be dots. It's going to be your AM trinomial method, okay? So we have our two parentheses. Since that's a minus, since I'm multiplying to a negative, my signs are going to be different. 1 plus, 1 minus. And they have to add to negative 13. So I break up my x and x. What are multiples of 30 that are going to add or subtract to negative 13? 15 times 2 gives me negative 30, if one of them's negative. And then if I wanted to add to negative 13, it would be negative 15 and positive 2. Now be careful with this one. I think there was one like this on last week. It's tempting to then pick your answer as positive 2, negative 15, but remember when you're solving for the zeros, you take it one step further and you set up a T-chart, set each factor equal to 0, and then those signs are going to change. So it's actually going to be x is equal to negative 2 and x is equal to positive 15. There she is, D. So what I want you guys to make sure you do then when you check this, plug the original x squared minus 13x minus 30 in your calculator, go into the table, and just make sure, remember when you find the zeros, your y value is equal to 0. So that should happen at negative 2 and 15. So I'm checking that. Okay, at negative 2, yes, that works. That's a 0, and then 15, you'll just scroll. 15 is also a 0, okay? So that's our strategy for checking. Okay, question 21 says, if f of n equals your n minus 1 squared plus 3n, which statement is true? So they're saying, they give you that notation again, where f of 3 equals 2. So remember, that is the point 3 comma negative 2. This is the point negative 2 comma 3, if I was looking at a table. So you could do, so those are all just, that's a special notation to show you points. You could plug each one of these in for n and solve. So you could plug 3 in for n and see if you get negative 2 as an answer. In this case, you could plug negative 2 in for n and see if you get 3 as an answer. Or you could check all of these at once. by just plugging in this into your calculator, into your y equals. Remember, f of n or f of x really means y equals. So you can go plug that in x. Remember, you have to use x instead of n. So x minus 1 squared plus 3x. Whoopsies, don't do what I just did. Woo, crazy. Let's clear that out. Okay, parentheses. X minus 1 squared, tab out of that, plus 3x. And then go into the table. And we're looking for these points that I wrote up here. So we're looking for the point, okay, 3, negative 2. Is that one of the points? No, it says 313. So goodbye to A. How about the point negative 2, negative 2, 3? Is that a point? Yeah, that is. So B works. Negative 2, negative 15 does not work. And if you went down to negative 15, you would not see a 2 there. That would not be a point. Okay, so the strategy is, again, check your table. So it's a y equals check your table strategy. Okay, question 22. Which function could represent this? I'm sorry, which chart could represent this function? So again, f of x means y equals. Plug that in. Check your tables. I'm going to show you guys the long way of doing it, and then I'll show you the short way. First things first, you know that this is a linear function. So your slope is negative 2, and your y-intercept is 6. So I'm going to look at all the y-intercepts. That's when x is equal to 0. I need my y-intercept to be 6. So automatically I can say goodbye to B and C because they have 4 and 8. Okay? Then what I can do, my slope is negative. So that means my table, if my x values are going up, my y values should be going down. These y values are going up. Right? It's going 6, 10, and they're growing. So I'm adding to those. These I'm subtracting to. So it has to be D. Okay, you could also plug in 2 points to find your slope formula. But D is my answer. Let's check Y. So in Y equals, you're going to plug in your negative 2x plus 6. And then you're going to go to your table. And just make sure that these points match. So 0, 6, 2, 2, 4, negative 2, and 6, negative 6. So that one, I would say the strategy would be to plug into your y equals and match with the table. Okay, those are a lot of the same strategies, but they are really effective and they help you with multiple choice. 23 you can cross out. That one we did last week. 24, we're going to solve 24, and then I'll show you guys how to check it. If you notice, there's 2 different types of answers here. There's 14 and then 14/5. So you can really eliminate 2 of your answers if you plugged 14 in or you plug 14/5 in, and if they don't equal the same thing on each side. But you do still have to solve it because you need to know what way the inequality is going. So let's go ahead and solve this one. 2h plus 8 is greater than 3h minus 6. I like keeping my variables on the left side of inequality, so I'm going to subtract the 3h over. So I have negative h plus 8 is greater than negative 6. Now I'm going to subtract the 8 over to this side. So I have negative h is greater than negative 14. And then we have to get h positive, so we have to divide by negative 1. And when you divide across an inequality, I know you guys all are raising your hands over there telling me what you need to do. The inequality flips. So it's going to be h is less than 14. Anytime you divide or multiply a negative number across an inequality, you flip the sign, okay? So it's going to be h is less than 14. So that would be your answer, A. What I would say the strategy would be is to plug in 14 to make sure it checks out. Now, it's not going to be perfect because it's an inequality, but when I plug 14 in for h on both sides, I'm going to get the same answer. It's just not going to be perfect because it's a greater than symbol, so that's why you have to also solve this one. Okay, and question 26. What is the product? So there's a vocab term there, product of 2x plus 3 and 4x squared minus 5x plus 6. So you need to know what product means in order to solve this problem, and it means to multiply. So we're going to be multiplying this binomial times this trinomial. So you have to put them in parentheses when you do that, and we're going to have to FOIL this. So you have to multiply the 2x by all 3 of those numbers, and then you have to multiply the 3 by all three of those numbers. Okay, and then I'll show you the way of checking this after we go ahead and do the long way. So we want to multiply all of these. So 2x times 4x squared, you multiply your number, your coefficient, 2, by your coefficient of 4, so that's going to give you 8. And then you multiply your x times your x squared. So you keep your base the same and add your exponents. That's going to be x to the third. Okay, you do the same thing over here. So 2 times -5 is -10. X times x, x squared. Then 2x times 6. So you can only multiply the 2 times the 6 to get 12. The x has nothing to multiply to, so it drops. All right, so we're done with that one. Now we have to multiply 3 by each one of those terms. So 3 times 4 gives me 12x squared. 3 times -5, -15, the x drops. And then 3 times 6, -18. Sorry, that should be +18. It's +3 times +6. Okay, and then from here, we're going to combine like terms. Is there anything to combine with the 8x to the third? No, so that's going to drop. And if you look at all your options, they all start with that, so that's a good sign. But we can't eliminate any just yet. Then I'm going to see what I can combine with my x squared. So I have a -10 and a +12x squared. So that's going to combine to be +2x squared. So I can say goodbye to A and B. Then I have my x's I can combine. 12 minus 15 is -3x. And then the 18 just drops down. My answer is C. Now I'm going to show you guys how you can check this. So as long as you set it up correctly, this right here, when you set up that you were multiplying these two terms, is going to be equivalent to your answer if you were to plug them into y1 and y2. So this is one of those checking to see if they match strategies. If you plug that into y1 and your option into y2, they should match because they should be equivalent. You didn't technically change anything. When you multiplied, you just changed the format, not the actual function. So if you do your 2x plus 3 and then 4x squared minus 5x plus 6, and then in your y2, you can plug in your answer of 8x to the third. 8x to the third plus, tab out of there, plus 2x squared. Make sure you plug this in right. Minus 3x plus 18. And then when you go to check your table, you should have matching y's, which we do here. So that's a good sign that we did that one right. Okay, so this is your y1, y2 match. All right. So now, let's see, 4, 5. These do not go in order, it appears. We're on number 9 and 10, okay? But it's just the next one in the packet. I guess we didn't put in a 6, 7, or an 8, which is okay. Makes us feel like we did more problems. Okay, so question number 9. What type of function is given below? And they want us to just graph this guy right here. So it's an x squared function, so we know that that type of function is a quadratic. This one, the x squared is positive, so it should open up like a smiley face. And they didn't give us any, it's not a word problem, and they didn't give us a domain restriction. So when you graph this, it's really important to remember that you find the symmetry, right? We need to make sure it looks like that perfect U, so we need to find our middle point and the symmetry when you plug that in your calculator. So in my y equals, clear everything out and put your x squared minus 4x minus 1, and then go to the table. We're looking in our y values for when the numbers start to repeat. Okay, so I see 20, 20, 11, 11, 4, 4, -1, -1, -4, -4, and then that -5 in the middle. Okay, you can graph, you don't have to do the 20s if you don't want to go that high. You can start with the -2, 11, -1, 4, 0, -1, 1, -4, 2, -5, 3, -4. This point right here, that middle point where the symmetry starts, That's a really important point. Circle that one and we'll talk about what that is. 4, -1, 5, 4, and 6, 11. Okay, so make sure you have that perfect symmetry going on there. Those are the points you want to plot. That middle point is your vertex, or in this case, it'll be your minimum. That is the most important point. You always have to have a vertex with a quadratic. So let's go ahead and plot these guys. -2, left 2, up 11, 2, 4, 6, 8, 10. It's a little off the graph. -1, 4. Over 0, whoopsies, down 1. That's not a graph plot. Over 1, down 4. Over 2, down 5. Now these are all going to match on the way up, so you just have to go 1 over and match them up. 1 over, match them, 1 over, match, and 1 over and match. Okay, so there's your quadratic. Make sure you connect it nicely and it's like nice rounded off, not like a V-shaped. And go ahead and label it. Okay, and then it says state the equation for the axis of symmetry. So you can do this algebraically, or you can do this by looking at this graph. This one, the axis of symmetry is the line that you can draw right down the middle that goes through the vertex, and it cuts your quadratic in half so that it looks the same on the left and the right, okay? When we think symmetry, we think the same on the left and the right. So you would draw that line down. That equation, it's a vertical line. So anytime you think vertical line, you should think of Vux, which means it's an x equals equation. And it cuts through the x-axis at 2, so x equals 2. Okay, the other way to solve that algebraically, if they ever said algebraically, you'd have to do the formula, which is x equals your -b over your 2a. And remember, your a is the number in front of your x squared. So we don't have a number there, so we know it's 1. Your b is -4, your c is -1. So I'm plugging in just my b and my a here. So x equals negative, and your b is -4, so you have to do double negative there. All over 2 times 1. X equals, that's +4 over 2. X equals 2. So both works here. If they ever asked you to solve algebraically, you just have to use this formula of the x equals -b over 2a. All right. And question number 10, this is the first time in this packet that we've seen a function like this with these bars. These are absolute value bars, so that's an absolute value function. Okay, these are, it's always important to like visualize what this is gonna look like before you graph it. These are in the shape of a V. So similar to the quadratic where you have to find the symmetry, right? And that middle point is your vertex. Same situation with the absolute value. You need to find the symmetry because you have a middle point of a vertex there, and you want to make sure you have the same on the left as you do on the right when you graph this, okay? So I'm going to make room for my table. I'm going to plug this into my y equals. Those of you who forgot where the absolute value bars are in your calculator, follow with me. So go into your y equals, hit the math button, and it's over, tab over on the right, NUM, and it's ABS for absolute value. You can go ahead and plug in your x minus 3, and let's get the table, find our points. So I can see my symmetry starts at the zeros in the middle there, then it goes 1, 1, 2, 2, 3, 3, 4, 4. So those are the points I'm going to graph. So -2, 5, -1, 4, 0, 3, 1, 2, 2, 1, 3, 0, 4, 1, 5, 2, 6, 3, 7, 4, 8, 5. Okay. And then let's go ahead and graph those points and make sure they look like a V when we do so. So -2, 5, 1, 2, 3, 4, 5. -1, 4, over 0, up 3. These are going to go down as if they are aligned. Just be careful that at your vertex you stop, over 3, up 0, and now we're going in the other direction. over 4 up 1. So we're going this way now, okay? So you want to make sure you have that V shape not like a line. If you only graphed half of it, you wouldn't graph an absolute value, you would graph a line. So you have arrows on both sides. We're going to label this y equals x minus 3. And then it says explain how the graph of y equals the absolute value of x minus 3 changed. Another word for changed is transformed. And that's what the word that you guys are used to hearing is transformations from the original y equals the absolute value of x. So if you're looking at the difference, it just has a minus 3 there on the inside. We know any type of transformation that happens on the inside means it's moving left or right. You can look at your graph to verify this, but a minus on the inside means right 3, which you can tell the original started at the origin and now it moved to the right 3. So that's all you have to put for that one. Let's also write the domain and the range for this function real quick. So domain, since I have an arrow left and right, the domain and range are going to be all real numbers, or negative infinity to positive infinity. And my range, how low did I go to how high? So the lowest point, you always bring it back to the y-axis. The range is from 0, and it's including 0, so it's a bracket. 0 all the way up to an arrow, so infinity. Okay, moving left or right doesn't change anything because since I have an arrow left and right, my domain's all reals, it will always be all reals. If this moved up or down, that would change your range, okay? All right, guys, great work today. Thank you for joining me. We look forward to seeing your work submitted by Sunday. All right, have a great day. Bye-bye.